With this problem, number 57, where we're trying to justify why if we measure uh, the angle in degrees, why is the derivative, this negative 180 pi over 180 sine of the degrees? Well, what we're doing is, because we do calculus in radian measure, so what we got to do is we did right here. What we did right here is we did that conversion. Remember, if I have 30 degrees and I want to change that into radians, I'm going to multiply by pi over 180, which gives me pi over 6, right? So we've got to do this. We're going to do the derivative in terms of radians. So I wrote that. And if I take the derivative of this, the derivative of the cosine is the negative sine of that original thing. And then if I use the chain rule, I got to multiply by pi over 180. So, and then we're going to convert it back to sine. So what this is the derivative when x is measured in degrees. Now I went out and I graphed this out of Desmo, and what you see is the derivative's a lot smaller, right? It's a lot smaller values than what the typical derivative of cosine x is. Okay, and the reason is you're only changing for every, now slope is the unit rate, right? So for every 1 degree change, the position's not of the original function is not changing as much as if you're changing 1 radian, because 1 radian is about 60 degrees, right? So what happens, you're changing units. So what I did is I went back and I did this. So suppose that I'm walking at 5,280 feet per hour. Well, that's the same thing as a mile per hour. So if I'm going to this other unit measure, you see how the rate of change is going to change. So if you're changing units, your derivative is going to change because you're either not moving as much or you're moving more. So I hope that makes sense why. I mean, the big point of this problem is do all work in calculus and gradient measure, especially with trigonometry. I did think it was interesting that the slope was 0 at 180 because that's when it's reaching a maximum. So, same thing at 0, same thing at 270 degrees, right? So, hope that helps.